All right. So, I'm going to introduce now Matt Allington. He came all the way from Australia, so let's give him a round of applause just for making the trip. Thank you, Matt. Matt has such a gift, I think, for explaining DAX and for explaining Power BI. I was in one of his sessions at the Business Application Summit, and I truly was like, wow, I think I get this. Way before I started actually trying it, but he did an amazing job explaining it, so I think we were really lucky to get his insights into DAX and his presentation topic today. Also, another thing to possibly talk about is his books. He's got these two great books, not only on Power BI, but also Excel, that product nobody can really kill and is always going to stick around. So learning a little bit something about both products is always a good idea. And with that, I'm going to get off the stage and leave it to Matt. So there you go. Thanks.
Okay, thank you. Thanks for having me. Was Gregory, I think we were emailing, right? I'm not quite sure what happened before that, and decided that while I was in town, it would be a good idea to pop down. I've never been to Oregon or Portland before, so it's great to be here, so thanks for having me. As you can see on the screen, I am going to give away a couple of copies of the book at the end. So if you're in the room, if you hang around long enough, this is part of the plan, right, to get you to stay. Like if it's really bad, hopefully no one will leave. So if you'd like to enter, there's the email address, or you can use the QR code. The next couple of slides are going to have that email address on the bottom, but just basically tell me which book you want to go in the draw for, and hopefully, with the demo gods treating me well, I'll be able to draw it using Power BI at the end of this, but we'll see what happens. Okay, so yeah, the topic is DAX as a query language. Let me start off just a little bit more of my background. I'm just an Excel guy, actually. I worked for Coca-Cola for 25 years, and I did a whole lot of roles, started off in sales, and moved into various administration roles in IT at one stage. But at the core, I've actually always been a data guy, and I think, I was one of those guys that used Microsoft Access or IBM Query, if you've ever used some of those tools. So I do a lot of online consulting. I've actually got some of my clients here today. Doug, right? So I've actually got clients all around the world that I do consulting work for. And I also do quite a bit of online training with people around the world. So if you're interested in any of that stuff, you can check me out at my website. So I just want to get a sense of who you are before I move on, just so I know who I'm talking to. So who would put themselves in this like SQL IT Pro, or maybe not even Pro, if you prefer, group? Who? Show of hands, who's in that? All right, that's less than half, I'd say. I think it was 42.5%, so very good. So who would class themselves as an Excel, Power BI, sort of more of a business user pro? All right, so there's some people that are missing out. I think that was about the same, 45%. All right, so just a sense of DAX skills. Who's a 0? Who would be a 0? Okay, 430. And then who would be a mid-range sort of person? Okay, good, so that's great. And then who's a pro? Couple of pros around the place. Hey, okay. All right, good. So that's good. So hopefully, I think there's something in this for most people, and we'll talk about that as we get in. So the topic is DAX as a query language. Particularly if you're an IT pro, you'd be used to SQL and the SQL query language, and I'm going to try and show you the similarities and the differences. So yeah, please ask questions as we go if you like. Also happy to take questions at the end, all things going well. There's a gentleman that asked about exporting more than 30,000 rows. If you remind me at the end, all things going well, I think I can show you how to solve that problem, but we'll see how we go. But then you'll have to know DAX is a query language, so you better pay attention, otherwise you won't be able to extract it. Okay, so let me start off by talking about the DAX language as it is normally used, which would be the way that most of you know of it. So DAX stands for Data Analysis Expressions. One of the reasons it's great is it's good for us Excel people. So, I haven't gone to university and studied IT. I just know Excel functions. I know Excel and I can get stuff done. And so the DAX language is very similar to Excel. It's a functional language. And all that means is a function is just a black box, right? You pass in some inputs and it spits out some outputs at the other end. That's all a function is. So everyone's familiar with sum in Excel. You pass it a range and it gives you the total of that range. And that's what makes, one of the reasons DAX is really good and accessible for Excel users, because it's also a functional language. Now, some of these things now are less obvious, but a DAX function or a regular DAX function always returns a scalar value. Now, the best way I describe a scalar value is it's a number that can be displayed in a cell, a single cell in Excel. All right, so it's either a number, text, date, Boolean, something like that. And so a couple of examples, so total sales, this is a SumX, something more complicated, similar to what Brian was showing up there before. This is the expanded version of the formula that Brian was showing. So that's the common usage of DAX, and anyone in the medium to pro would be very familiar with that. Okay, so let's talk about DAX as a query language. So the main difference is that a DAX query doesn't return a scalar value. In fact, it can't return a scalar value. It must return a table. And once again, very familiar, I guess, to many of the SQL folk. So most of the functions are the same within the DAX language. So filter is a function that returns a table, but there's also some special commands, which we'll have a look at a few of these as we get in. So, and then there's some I wouldn't say these were query-only functions, but summarize, add columns. You certainly can use them inside regular DAX measures, and in fact, I'll show you how we do that as I get into the demo. So what happens is you write a query. You need an editing tool to write the query, sends the query to the back end, and gets the result back to the database, and it's displayed on the screen. It's always a table, and you might get 0, 1, or more rows, so depending on what the query is. I want to give you a bit of context on why would I care about this. So the whole demonstration I'm going to do is to really try and take the concept and give it some tangible use cases for you, and to sort of so you can see where the value comes from. So the first thing is that you can extract the underlying data from your table, or from your data model, more correctly, I guess. And so as you start to invest time and money in these tabular data models, there's going to be times when you want to get to the underlying data, right? So DAX as a query language is a way of either getting the detail or getting the summarized view of the data there. Also, you can use DAX queries to help you understand DAX better. So if you've got a problem with a formula, you can't work out what the problem is, you can extract the table piece of that formula and materialize it in front of your eyes so that you can see what's going on. And in my experience, being able to see the underlying table makes the whole experience much easier and easier to digest, and so I'll show you that as well. And then also checking performance of measures, and I'll show you an example of that as well. So there's 3 use cases, and I'll cover those in my demos. Okay, so to start off with, I'm going to, and I haven't opened up my files, but I'm going to open up a Power BI data model and connect to it using DAX Studio, and then we'll have a look at the start of the query language. So I did a late change on my laptop, so I haven't opened this up. Okay, so here's my data model. So this is just one that I threw together. I think I might have increased the rows just to make it a little bit slower and return more rows of data so that it's something meaningful. It's one of the problems with using a database like AdventureWorks is it's so small that you can't really show any real performance issues. 1 trillion rows. Yeah, 1 trillion. Ooh. All right, so here I am in Power BI Desktop. This is an import mode, so here's my data model. So I've got 3-dimension tables, or lookup tables as I call them, at the top, and I've got one data table down the bottom. And if I jump over here to the data view, look at the sales table, down in the bottom, oh, my zoom's not going to be nice to me today. So down the bottom left-hand corner, if you can see it, there's 6.7 million rows of data in that table. And all of these keys, or foreign keys, are all linked to these other tables. Okay, so now what I'm going to do is I'm going to open DAX Studio. So this is a free product, community built. The Italians are very involved in this. I know there's also some developers in Australia that are pretty involved. And so this is a free product, you can download it, and it's a lot like SSMS, SQL Server Management Studio for the SQL folk. So when I launch it up, I have a choice. At the moment, I can't connect to an Excel Power Pivot model. I'll show you that later. But if you've got more than one Power BI desktop file running, you can choose which one you want. And you could also connect to a tabular server if you've got SSAS running available on your network. So I'm just going to connect directly to the Power BI desktop model. And over on the right-hand side, it might work at this point, you can see the 4 tables. So basically it's just a pure representation of my data model, and I can see all the columns and the measures. So everything's here, and from here I can start to write a query in this editing box at the top. So just to sort of show you what can be done, I'm going to start off by, I think I'm in the wrong place here, just excuse me just to check my notes. Okay, so the first thing I'll need to do is anytime you write a DAX query, you always start with the word or the statement evaluate, which is a bit like select, I guess would be the equivalent. So you always start a DAX query with evaluate, and the most simple query you can write is just evaluate one of the tables, and that just says go and grab me the table. And so there's a run button here. I can also hit F5. I normally hit F5, but I'll try and hit run just so that I can show you what's going on. And then down the bottom of the screen, you can see here's the results. That right down the bottom right, it says 23 rows, and here they are materialized in front of you. Now this materialization, I just want to come back to that point I made. This is actually what makes this such a valuable skill and tool to use, because these table functions, as they're built inside measures in DAX, you can't see them. And it makes it very difficult to conceptualize what's going on. And sometimes just the act of seeing the table materialize in front of your eyes can be enough to solve a problem. Okay, so I can evaluate an existing table, but that's not overly exciting. What I can also do is I can run any function that will return a table, I can use in its raw form. Whereas inside regular old Power BI desktop, any function that returns a table can only be used as an input to another function that returns a scalar value, if that makes sense. All right, so let's take values of the sales table quantity column. So what does values do for all the intermediate DAX people? Values returns a single column table of all of the values in the current filter context. So there's no filters being applied at this stage, so it's just going to return a single column table of all the values in that sales quantity column. So there's, what was it, 6.7 million rows in that table, and there's 1,042 rows, or 1,042 different unique values in that column, so that's basically the cardinality. I can also use an order by quantity, I guess. So I can do that and run that again, so I get a sorted order, and I can change it. You know, there's a descending keyword, so I can make it run the other way. And the other thing though is I can't do an order by a column that's not in the query. So I can't say order by sales customer ID, for example, because sales customer ID is not part of this table, and therefore it throws an error, and you can see that it wasn't able to execute that. All right, so let me just write something a little bit different. I'm going to start off with evaluate the IntelliSense is a little bit finicky. Evaluate the products table. I hit F5 that time. So there's the entire products table that's been materialized on the screen, so 504 rows. I could also use another function like distinct, which is very similar to values, and certainly in this case it's identical. So give me the distinct products, so give me all the distinct prices in the products table, hit F5 again. So there's all the distinct pricing down here. There's 254 distinct prices. But because this is a table, I can now start to embed a whole lot of other table functions around it. So now my mouse is going to play up. All right, can you see it okay? Sorry, it's just a bit awkward for me to zoom in. So now that I've got this table, I can put this table as an input into another table function, like filter. So I can say, filter, I want to filter this table, which I can see down the bottom here, and I only want to keep the rows where the product's price, don't know why IntelliSense is not working, is greater than or equal to 100, for example. So run that. And so now it's come back with 178 rows. So you basically start off with the first table that you can think of, and then you start building around that to end up with the table that you want to end up with. All right, so that's a pretty good intro. So just let me wrap up a couple of points there. So DAX Studio is the tool that I normally use. You can use SSMS, actually, SQL Server Management Studio, but that's not within my skill set, so I don't normally do that. Every query starts with evaluate, and you can use any function that returns a table. So that's basically the rules of DAX queries. Okay, so next use case is to actually summarize data, and I'm also going to have a look at performance while we're over there. So before I do that, though, I just want a brief introduction to the Verde PAC engines. So Verde PAC is the name of the technology that sits underneath Power BI Desktop and SQL Server Analysis Services. And there's two distinct engines, and these engines work cooperatively but independently in many ways, and they have a very special function that each of those engines does. So the first one's called the storage engine, and this engine's really fast. It's the compression engine. It has the job of compressing your data. That's the engine you can thank for getting your 100 megabyte workbook down to 10 megabytes. And it's also capable of returning a mathematical result without having to decompress the data. So you can imagine if you got a 10 or a 20-fold compression, but the only way you could actually come up with a total would be to decompress the data first. That would be a disaster. So the storage engine, as long as you write your formulas correctly, is more than capable of doing that. It's also multi-threaded and cached, which is really important, and that's why you'll see some improved performance on the second click or when you return using the back button within many of your reports. Okay, so the formula engine is almost the flip side of that. So it's a really smart engine. It's got unlimited capability, and it does work in a row context, although even that is a little bit a misnomer because there's a whole lot of optimizations under the hood. So you shouldn't necessarily think that the formula engine only works in a row context, but depending on how you write your formula, it can be a problem. And it's single-threaded and not cached. And so if it has to work through a 1 trillion row database, and there's no ability to go back and retrieve that result a second time round. All right, so why am I telling you all that? Okay, well, let's get back in and have a look at another demo where we're going to summarize tables. And so first of all, what I'm going to do is I'm going to do a cross join. So there's a cross join function in DAX. And cross join just takes two tables and stitches them together with no care of whether there's any logical relationship. So if I just take employees and customers, in other words, if I guess the end game might be to know which employees work with which customers. So one way I could do it would be like this. The trouble with this is that it's basically bringing back all possible combinations, even if they don't exist in real world. In fact, look at this query. It's taking quite some time to run, and cross join's not an overly efficient function. Okay, so there's the results. There's 500,000 rows of data. But what I can do is I can turn on server timings, and I'll need to rerun this. I meant to do this before. And so what this server timings function allows me to do is it actually analyzes which of those two engines has been given the task and how much each of the engine is working on the task at hand. Whenever you're using server timings, it's important to clear the cache because of the reasons that I mentioned before, that the storage engine has its own cache. And so if I run that again, we'll have a look at how long it takes based on each of the engines. So formula engine and storage engine is pretty obvious. And basically you want to see a lot of activity over here in the storage engine, and you want to minimize the activity over here in the formula engine. That's the best outcome. And you can see in this case, we've got exactly the opposite. And basically that means that the formula engine, the slow, non-cached, inefficient engine, is doing all the work. And so that's not the approach that we want to take. Okay, so the real objective here is I want to try and get a subset of employees who are working with particular customers. So I'm going to show you another function called summarize. So this is an advanced table function. Now with the summarize function, basically what we're going to do is we're going to start with the data table, so it's the sales table. Maybe I'll just bring that up on the screen. So we're going to start with this table here, because this is the table on the many side of the relationships. Then we're going to go and grab any other column from any other table and create a summary level table. So that's the general pattern. Anytime you use summarize, always start from the data table. So we're going to go summarize the sales table. And now I'm going to go and grab the employee last name. So who are the employees? In fact, let me just run that. So I'll clear the cache and run that. So that took 4 milliseconds. And if I jump over here to the results, you can see it's just a list of all the names of all the employees. But now I can also add the customer. I might just add the customer ID, and I will clear the cache, run that again, and now you can see that I've got 1,850 rows, but these are all the true relationships between employees and customer IDs within the database. Okay, so that's interesting. What if I wanted to know how many sales each of these rows took up? So there's a couple of approaches. The one I'm about to show you is inefficient and not recommended, but I'm going to do it anyway. So you could just go, so basically you get to create a new column. So I'll say, call this total sales. You give it a name of your choice, and then you can refer to a measure. So I'm going to make sure I get the right one here, total sales quantity. And then I can add well, let me just leave it there. So if what's going on here? Have I got the Brian Gremlin? Looks like it's still running or something. All right, it doesn't look very happy. I don't know why it's doing that. Let me just quickly restart it. Connect. Oh, lucky I copied that. Okay, so there's the query starting off with the last name, create a table with all the customer IDs, and now there's the total sales. But this is actually relatively inefficient, and if you want to learn about these, I've actually got some blog posts, but I learnt from SQL BI, where most of us. So the better way of doing it is to use this add columns function. And so basically what you do is you let the summarize function create the two tables of unique values, and then you let the add columns function go and add this extra data on, and this is much more efficient. And so if I run that, I mean the timing is so fast that it doesn't really matter. Remembering this is a 6.7 million row, I realise it's not the biggest table in the world, but it's not insignificant either. So server timings, clear cache. So if I run that again, you'll see that it took, well, 8 milliseconds in the storage engine, and if I ran it again without clearing the cache, only took 1 millisecond. And anything under about 100 milliseconds, it just has to be you're receiving an email or something like that, and it can throw the numbers off. So don't take it too much to heart. All right, so that's that. Now there is another function then that replaces this summarize add columns, and this is called summarize columns. This is a relatively new function, and it basically does the same thing, except that you don't have to specify the starting table. And that looks like I've got too many. So you don't have to specify the starting table, and it's more than capable of efficiently adding these additional columns in. So that's a more modern way of doing it, and yeah, the results are the same as you can see. Okay, so before we move on, I just want to show you one other thing that's pretty cool. Down in the bottom left-hand corner, you'll see this DMV section. So once again, those of you who are familiar with SQL would be familiar with DMVs, but it's relatively new to me. So there's one called Discover Memory Usage, if I can find that. Here it is. So all I have to do is take this DMV, drag it onto the canvas. It looks a lot like, it probably is SQL actually. If I run that query, it goes away and it gives me a list of all of the columns in the database and how much memory that they're being used. And there's a lot of tools out there that use this technique to extract data into Excel and various other tools. But you can do it manually using DAX Studio. And there's another one called MDS Schema Measures, this one here. And if I execute that one, that extracts all of the measures from the database, including their name and their formulas. And so that can be useful for documentation. But once again, there's other tools that do that. But DAX Studio is not a bad way of doing that. Okay, so that's summarizing tables. So just a couple of key points, sorry. So you really want to see this storage engine having all the activities. So that's the key to fast, efficient workbooks. So if you're doing any debugging and you're seeing slow performance, it's likely that it's the fact that the formula engine's doing too much work. I've got this slide in, and I can make this available afterwards, but really just so that you've got some documentation of the things that I covered during the session. So add columns and summarize, you can see there. Okay, so let me get into testing the measure efficiency, and I'm going to show you a measure that's a little bit of a problem child. So let me make sure I've got this right. Okay, so I'm going to go back to Power BI desktop. And let me find my measure over here. Total sales quantity, total sales value. So here's my measure, and there's actually a problem with this measure. And so the performance is pretty bad. I think if I just whack this in here, let's have a look at how long it takes. Certainly not BAM like the 1 trillion row that Adam showed before. Okay, but the performance of that measure is not good. I guess you could understand that. So what I'm going to do is I'm going to copy this measure into the clipboard, and we're going to go over to DAX Studio, and I'm going to go evaluate, and the name of the measure was, let me get back to, was total sales quantity, I think. Now, do you remember the problem? One of the rules of DAX queries is that you're not allowed to return a scalar value. So if I try and run this query, it fails because this is a measure, and a measure returns a single value, and you're not allowed to return single values in queries. And so there's a function called rows maybe, it's called row, where you get to specify the name of your row, so I'm going to call it my test, and then the expression to return that. And so when I run this formula, I do get a result. I get a single column, single row table containing the measure. So it's just a bit of a hack or a trick to be able to materialize a measure in front of the screen. So that's how you can start off with the testing process. And so okay, so what I can do is, let me go over to the server timings. I better clear the cache. That took 3 milliseconds. That was too good to be true. So if I run it again, still pretty quick actually. I wonder whether I've got the right one. Yeah, I brought the wrong one. I've deliberately set up this total sales value measure to be inefficient so that I can demonstrate what's happening here. So there you go. We've got this this query that's being run. The formula engine's taken 2.5 seconds, not that long. The storage engine, also notice here, the 1.8, that's the multi-threading thing happening where the job's been cut up into pieces. And so it actually took 8.5 elapsed seconds, but all in all, 8.5 processing seconds, 4.6 elapsed seconds for a total of 7. So there's something wrong with this measure. And so DAX Studio is a great way to do some debugging because you can see what's happening under the hood. In fact, over here, there's the query plan, and there's even a little highlight here. So one of the things you have to watch out for is this thing called callback data ID. And anytime you see this inside your query execution, what it's saying is there's a handoff between the formula engine and the storage engine. They're passing it back and forth. They're saying, you do it, no, you do it, no, you do it. In fact, they're doing one row at a time. So that's normally a sign of an inefficient formula. So what I can do is I can define a measure here, and I can define a local measure just inside this instance of DAX Studio. But one of the things I can do is I can redefine the measure that I had inside my data model. And so if I redefine exactly the same name to measure, now some of you may realize this is not best practice, but because I'm defining a measure locally, I have to specify the table. So I'm basically overriding the formula from the measure coming from the data model. Okay, does anyone know what's wrong with this formula? Does anyone want to have a suggestion on what I could do to improve the performance? Zoom in, yep. That's it, yeah, I sort of can't actually. Let me try and, yeah, there's something playing up with my Zoom. I might be able to do, I don't know whether this will work. It's a good question. I actually had to test that myself when I was practicing because I couldn't remember. But no, the defined measure comes first. So, but maybe you haven't used defined measure before. So no, that's. Oh, well, I hope I'm right here. Let's just clear cache and run it. I believe it'll execute, but it will still take a long time. I hope I haven't crashed this thing again. Oh no, there we go. Okay, so the problem is that inside every measure is a calculate function. You can't see it. It's called an implicit calculate. And exactly as Brian showed us earlier on, what the role of calculate is to pick up the current filter context and pass it across when it's inside an iterator. And indeed, SumX is one of those iterators. And so SumX is working through the sales table. Well, that's one problem. It's working through the sales table one row at a time. And for every row in the sales table, it is, I'm making it worse, I think. Every row in the sales table, it's effectively converting the row context into a filter context on 6.7 million rows. And so what I can do is I could, instead of saying unit price, I could work my way through the products table, and for each row in the products table, I'm just going to take the products unit price and multiply that by total sales. So I'll clear the cache and run that. That took 18 milliseconds. And you can see most of the work got done by the storage engine, and the formula engine didn't get involved at all. Still got a callback ID, but there was only one in this case. It was first delegated and then returned the result. So now the fact is that just by coming in here and looking at these engine results, this is what gives you a clue of where the problem might be, and potentially having a look at these query plans, etc., which is a more advanced concept, but still something that's accessible. All right, so that's an example of how you can debug a measure. And then, of course, once you've got your measure, you can just now come and copy this. And I could come back in here, find my inefficient measure, and just replace it there. And then basically this model should now work a lot more efficient than it did before. All right, so moving on. So yeah, key points, you have to use the row function because you're not allowed to materialize a scalar value inside one of these tools. You can use define, it does come before the evaluate statement, and if you're going to do this, make sure you clear the cache because the whole point is you're trying to test the focus on each of those engines, ignoring what happens with cache. All right, so now I'm going to have a look at how you could go about debugging a formula where, not from a performance perspective, but maybe where you're getting a result that you're not expecting. And so I've got a formula here that is deliberately set up to be not working. You might like to have a look at that and see if you can work out what the problem is with this formula. But if I come to this matrix down the bottom, I've got my product category in the rows, and I'm trying to work out how many categories have got more than $500 million worth of sales. And you can see that, well, there's blanks have, and that's fine. The data doesn't have an entry there. But the bikes category's got more than $500 million sales, and so is the components. But when we get down to the grand total row, it's not working. It's not giving me the answer that I need. I'm expecting the answer to be 3 at that level. So something's wrong with this formula, and I'm going to show you how I would go about debugging that in DAX Studio. So same thing again. I'm going to come over here and find my, I'll just take this out. I'm on the wrong tab, that might explain it. Okay, here we go. So here's the categories. So I'm going to copy my formula, do the same thing as I did before. Come over to DAX Studio this time. This one is the, actually what I'll do in this case, I wasn't planning on doing that. What I'm planning to do this time is I'm just going to cut this part of the formula. So remembering that a filter function is actually a table function. So what I'm doing is I'm just grabbing the filter bit out of the measure, and I'm going to materialize that part of the formula on the screen so I can see what's going on. So let me move that, and I'll put it over here. It is a table, so I don't need to wrap it in a row. And I might just put a wrap here. And now I'll clear the cache, and I'll run that formula, and I'll see what it materializes. So here's the results, and it's giving me everything, which is exactly what the 5 said. But sometimes the act of seeing the results of that table materialized on the screen is enough to trigger you to think, well, why am I getting every single category here? I would expect this table function to return just the tables with more than $500 million. And the issue is related to the previous one. In this case, there's no calculate around my sum function, and I need to add the calculate in order to be able to force the engine to take the filter. So the value, it works through the products category table one row at a time. And now the calculate says, before I add up the total sales, I'm going to put a filter on just that one category. And so if I run that now, not like that, but like that, then I get the results I expect, the 3 rows. So now I know that I've got my formula incorrect. I can copy that formula and come back and reinsert it into my model. And so look, this is a simplistic example, but I certainly have used this quite extensively myself when I just can't work out what's going on, and it happens. Doesn't matter how long you've been doing this, you're going to end up with things like that. And now you can see on the screen that I'm getting the total 3 that I expected. And the point I'm trying to make is that just the act of materializing that table, that piece of the measure that you normally can't see, can be enough to make a difference. Also, incidentally, I'll just copy this piece again. It's probably still in my clipboard. If I copy that table function, you can also come to the Modeling tab and click the New Table button, and that allows you to use a DAX formula to return a table. So this time I can just pass the filter function straight into there, and that will materialize a table. And I can jump over here. There it is. I didn't give it a name. And if I come over here to the table view, I can see the table with those 3 results. So I'm not saying you should or you shouldn't do that. I'm just saying you can do that, particularly if you don't have DAX Studio. That can be a useful way of materializing a table. Okay, so key point, you can actually physically see what's going on. You can use that new table function in Power BI, and the whole point is, first of all, work out what's going on with your table. Once you've got that sorted out, the rest will fall into place. Okay, so I'm going to look now at extracting data into Excel, and for this example, I'm going to switch to Microsoft Excel. So I've got a VentureWorks data model here in a Power Pivot workbook. Now, if I jump back to DAX Studio here, if I click Output, you'll see that there's an option to output to a file. You can send it to CSV or a text file, but there's no option here to export to Excel. Okay, so I'm going to shut down DAX Studio. And here's my AdventureWorks workbook. I might just quickly show you the data model. Okay, so 5 tables. Here's the relationship view, diagram view. So same thing, star schema. I've got 1 extra table in this case. Okay, so if I'm going to, if I want to be able to export data into Excel, what I need to do is I need to launch DAX Studio from within Excel. And so there's an add-in, and so I can launch DAX Studio. And this gives me the option to connect directly to AdventureWorks. Now, even if I don't do that from AdventureWorks, I can still come over here and relaunch DAX Studio, and I should be able to connect directly to the Power BI desktop model that's running on my computer as well. So this is a sort of a bit of a workaround to be able to get that extract. And now, even though I'm still connected to my Power BI data model here, I can select output through to Excel. So I'm just going to put that into a sheet of my open workbook, and I'm going to do just something similar to what I did before, evaluate, summarize, columns, and I'm going to export the employees' last name and their total sales. So they both work, that's fine. And so if I run that query now, it's completed, 22 rows returned, but they're not returned to this window. They're returned, oops, I should have put them onto a new sheet. Luckily I had a bit of space there. It's returned directly into Excel. Now this one is a static export, which means if I run it again now, it'll overwrite. If you do a linked table export, you can actually save your query and your Excel workbook and have them refreshed and updated later on down the track. All right, so and then here's this AdventureWorks data model. Now, with the AdventureWorks data model, in fact, with any pivot table, if I double click on one of these cells, it does this drill through where it goes and grabs all of the data. And you're probably familiar with that in a regular Excel pivot table. With Power Pivot pivot tables, it's horrible. You don't get any control over what data comes back. You get these table names prepended on the front. So basically, that's not a very good experience. And so what I want to show you is that there is another way of getting data out of your data model. So I'm going to start off, sorry, just find my place here. So I'm going to start off by writing a query here. So I've got this summarize columns. Let me do summarize the products table. And I'm going to subcategory, and for each subcategory I'm going to extract total sales, which is total sales values, and then also total margin percent, I think I've got in there. So you get to override the name of the column if you want. Let's see if I got here. Oops, I'm in the wrong workbook. That's my bad. Let me copy that. Oh, really? Wow. Geez, I'm talking too much. Okay. All right, so I connected here to the correct model, total sales. Total. Okay, total margin percent, so I'll leave it at that. I can execute that. I might change this back to the grid just for now, run that query. Something wrong with it? Summarize products. Okay, so there's the result, and I can grab that entire query and I can come back to Excel. This is my Excel Power Pivot model, and I can go Data, Existing Connections, switch over, and these are my tables here that belong inside my my Power Pivot workbook. I can pick one of those tables at random. It doesn't matter because it's going to disappear in a moment. So and now I get the option of returning a table, not a pivot table. So there's the table coming straight out of my data model. And if I right click and I select table, edit the DAX formula, I can say, I don't want this to be a table anymore. I want it to be a DAX expression, that same one that I wrote. And when I click OK, that will go ahead and materialize that table directly inside the Excel workbook, which is a lot better than that double-click experience. Okay, so conscious of time, so I might just wrap it up there. I had a couple of other things, but just slight variations of the things that we've talked about. So I might just pause and see if there's anyone that has any questions or anything they'd like to ask me before I wrap up and try and get my prize draw working. I might do that while I wait to see if there's any questions. You might have left the run too late on that. So, but if you let me stay the night, I'll give you a book.
You can stay with me, Matt.
Okay.
Anybody else?
Does anyone see any use for DAX queries?
Yeah.
Okay. Well, let's see whether the demo gods are smiling nicely. If those numbers don't change, then there'll be no draw tonight. This is querying to an Excel spreadsheet on OneDrive, which has been populated by Microsoft Flow when an email arrives at a shared workbox in Exchange. Now, it's pretty cool, except it takes a bit of debugging. Okay, so there's my entries. Now, what I'm going to do... Okay, now don't get too excited here. I'm going to randomize the entries. Now, if you see your name, the wheel's spinning, remember. Don't get too excited. I don't want to hear any big yoo-hoo. All right, let's see. Randomize. Come on. Randomizing. Spinning the wheel. All right, that'll do. And here are the winners. Whoever these two people are. Who are these people?
Got one.
Okay, who is the yellow book? Okay, and green. Oh.
Congratulations. Yeah. That's awesome.
Okay, so thanks very much. Hopefully you've found that interesting. I might give the gentleman here a demo on the 30,000 outsider here when I get a drink. So, okay, thank you very much. I'll just leave.
Now, just to wrap it up, thanks everybody for coming again. Thank you everybody for coming to the workshops and being attentive. And I found that talk that you just gave extremely helpful. The fact that you can just start fine-tuning your DAX measures and then also, looking at queries. One thing that it kind of made me think about was Snowflake. Snowflake had just released their data warehouse up on Azure, and you can actually separate compute and storage and start fine-tuning your data warehouse in that sense that you can't really do, I think, in most cloud data warehouses. Except for Azure. Azure Data Warehouse, yeah. So we also have one more drawing for the people that put their business cards up front. So there's a $100 gift card to a Lee Gilmore. Is there a Lee Gilmore in the house with Alliance Systems? No, going once, going twice. Ron, you want to do the honors? John Larimer, there we go. All right. Congratulations. All right, Ron, I'll let you.
I think that my perspective tonight was really like I need it, right? From my perspective, tonight was a lot of fun, and it was just fabulous to see all of you guys come out and participate in this event we put on. I'm curious, of the people that are left, who's not a member of the Portland Power BI user group? A few of you, you know, and I would encourage you to get in touch with. Well, you should be, Adam. I would encourage you to reach out and talk to Greg. Sign up for the user group. We do these monthly things month after month, and it's just a great way to get and stay connected to this community. I want to thank all of our sponsors. I don't know if any of them are still here. Any of our sponsors still here? Scott, of course. You know, Scott also sponsors our monthly user group, Scott Lexicon. If you're looking for a job or if you need talent, Scott's your man. I also want to thank once again our speakers and our workshop trainers. Thank you guys for making the effort, for making this a really successful event. Was it successful? All right, I think we're going to call that good. So thank you, everybody.